Okay, this is Unit 6.5. Our objectives for today are the student will be able to use the property of logarithms to evaluate logarithms, use the properties of logarithms to expand or condense logarithmic expressions, and then use the change of base formula to evaluate logarithms. So hopefully when we finish this, these three things will be really clear to you on what to do. So, the first core concept is we've got these properties of logarithms. And this is if we let b, m, and n be positive real numbers with b not equal to 1, then these three rules will hold when you work with logarithms. So the product property, again, product is multiplication. So in both of these work both ways. So this is, again, read log base b of m times n can be rewritten as log b of m plus log b of n. Or if you've got addition, you can bring it to multiplication. You'll just find that for some it works helps to move it to this method, and some it helps to move to this method. Same thing with the quotient property. Quotient is division, so if we have log base b of m divided by n, then that can be written as log b of m minus log b of n. And the last one is the power property. Remember that if you have something to a power. So if we have log base b of m to the n, we can rewrite that as n times log b of m. So you can move that exponent out front and multiply it to the logarithm, and it still will give you the same value. So we're going to look at how we can use these to simplify some expressions. So when you look at example number 1, for these three problems, we're going to let log 2, so this is read log base 2 of 3, is approximately 1.585. And log base 2 of 7 is approximately 2.807. And we're going to use that to simplify these. And so we're going to use our properties that we have here along with these rules for our values of log base b of log base 2 of 3 and log base 2 of 7. So this one is division. So log base 2 of 3 divided by 7. I can rewrite that as log base 2 of 3 minus log base 2 of 7. And then we can take those values. We know that log 3 is 1.585 minus 2.807. And we can subtract those then to get our value for this, which would be 2 and so negative 1.222. If I did that correctly. Alright? So you just convert it from the division to a subtraction problem, and then you plug the values into the values they give you. So they're going to have to give you values to do these. So again, we're trying to get it so we can use either log base 2 of 3 or log base 2 of 7. So if we look at this, we can rewrite this one. We can change this 21 into 3 times 7. So now I can use my rule for addition here, and I can convert this to log base 2 of 3 plus log base 2 of 7. So the whole idea when you're doing these is whatever numbers they give you and the values they give you up here, you have to somehow convert this into these formats so you can use those values to solve it. So again, we're breaking the 21 into 3 times 7, then we're using the rule for multiplication to change it to 2 additions. But again, the reason we did that was we know the values for log base 2 of 3 and log base 2 of 7. So now we again plug those in, and so now it would be 1.585 plus 2.807, and so that would be 4.392. All right? And then the last one, log 2 of 49. So again, we need to get it into one of these, or both of them, depending on what we can use. And in this case, we can change this into 49, we can change into 7 squared. And then we're going to use the power property to move that exponent out front, so I can rewrite that 2 log base 2 of 7. So again, we change the 49 to 7 squared, then we move the 2 out front using the power property. And so this becomes 2, and we know this is 2.807. And so we can multiply that and get 5.614. So that's what you're going to do on these. You can convert it to whatever the units they give you, whatever values, and then you're going to work with that to find the answers. So I'd like you to go ahead and pause the video here and try this. So again, you're going to have to try and convert everything into log base 6 of 5 or log base 6 of 8 so you can work with it here. So go ahead, pause the video, try these 4, and then come back and see how you did. So on this one, again, division I can write as subtraction. And so log base 5 would be 0.898 minus 1.161. And if we do that, it would be negative 2.63, I believe, or negative 0.263. If we do the second one, so this 40 you should have broken into something that gives you 5 and 8, so I can break that into 5 times 8. And so this becomes log 6 of 5 plus log 6 of 8. And so now it's 0.898 plus 1.161. Which is 2.059. Okay. 64, using the 5 and the 8, I can rewrite this as 8 squared. And then I can bring the 2 out front. So 2 log base 6 of 8. So that becomes 2 times 1.61, 1.161. And so that would become 2.322 you should have gotten. In the last one, log base 6 of 125. I'm going to use the 5. I can write that as 5 cubed. And so now using the exponent, I can bring the 3 out front and go 3 times log 6 of 5, so that becomes 3 times 0.898. And so 24, 26. So if I did that right, it'd be 2.684. So you just have to, they're going to give you some logarithms and the values, approximate values, because they're rounded off. And then you're going to have to put these into the format that gives you, so you can use those values to find the answer. So that's the first thing you're going to do on this. The second thing we're going to do is we're going to use properties of logarithms to expand and condense logarithms. So to expand it, we're going to take it out and write it as addition, subtraction, or to a power. So if we look at example number 2, we're going to expand ln. Now remember, ln is log base e. So we can do the division. So division we can do a subtraction. So I can do ln 5x to the 7th minus ln y. So we use the property that says division can be written as subtraction. And you just keep it as ln, because that's what it was. And then I can still do this. I can change this, because this is 5 times x to the 7th. I can change that into ln 5 plus ln x to the 7th minus ln y. And then we're still not finished because we can still work with this 7 out front, or in the exponent, and move it out front, and rewrite it ln 5 plus 7 ln x minus ln y. And so that would be what's called expanding the logarithm. We take it out from its simplified form and we expand it out into addition, subtraction, and some multiplication. Alright, so that would be number 2. And then condensing it, we're going the other way. And so I'm just going to start here. We can move this 3 to the exponent, so this becomes log 9 plus log 2. And remember, there's no base in these, so it's base 10. 3 minus log 3. And then addition becomes multiplication. And 2 to the third, we can go ahead and convert that to 8. So we can go log 9 plus log 8 minus log 3. And then addition becomes multiplication, so that would become log 72 minus log 3. And then subtraction becomes division, and so this becomes log 72 divided by 3, which simplifies to log 24. And so that would be condensing it as far as we can go. So those are 2 other things. We're going to be able to expand it and condense it. So again, we've got 2 here that I'd like you to try, 2 to expand and 2 to condense. So again, if you'll pause the video and then try these and make sure that you understand it. So on this one, we're going to expand this. Again, this is multiplication. You cannot pull the 4 out first because the 4 does not affect the 3. It'd be different if this was in parentheses, then you would pull the 4 out first. But since it's not in the parentheses, we're going to break it up first. So multiplication becomes addition. And then we're going to bring the 4 up top and move it out front to expand that. This one's division. So the first thing we're going to do is we're going to go ln 5 minus ln 12x. But we still have this addition here, or multiplication, so we're going to change that. Okay? So you take the division, break it up, and then because that's 12 times x, we break the multiplication and addition to expand it. So that's what you should have ended up with. One thing we should probably do on this, let's see, does it make a difference? Yeah, we're going to have to put this in parentheses because we want to subtract the whole thing. So you want to be careful on this, because if I didn't put the parentheses, if I did this as division, working left to right, then I would end up, if I didn't put the parentheses, I'd end up with this. That, which we don't want. Okay? So you would have to put that in parentheses. So be careful on these, that you're careful on what you have to do first. So on this one, you'd have to put that in parentheses to get the right equation. So let's condense this one. So division becomes, now again, it's log base 10. If I just do that, that's all I can do on that one. Can't simplify it from there. On this one, I'm going to start 3 to the third power. I'm going to move that 3 up here. So let's go ahead and show that. And then I'm going to 3 to the third, I'm going to change that to 27. And then we become multiplication, so 4 times 27. Let's go ahead and write that. It's going to be 4 times 27. And 4 times 27 would be ln 108. and then subtraction becomes division. And then 4 goes into both, and so that would be ln 27 over 3, which then reduces to ln 9. So that would take it down as far as possible. So hopefully that's what you got. Next, our core concept, change of base formula. So when we go back to the original that we were working with, this log base 2 of 3 and log base 2 of 7, we don't, on the calculator, we can't find those the way they're written that way. But we do have what we're going to use next, which is what helps a lot, is what's called the change of base formula. And the change of base formula says if A, B, and C are positive real numbers with B not equal to 1 and C not equal to 1, then log base C of A can be rewritten as log base B of A over log base B of C. So if I take a number, let's put numbers in there, let's say log base 9 of 2. Since I can't do that on the calculator, I can rewrite that as log, and I can choose any base I want. So I could choose base 7 if I wanted. It'd be log base 7 of 2 over log base 7 of 9. Okay? So I can convert it, so if the book gave me values, I could do that. But what we're really going to use it for is, in particular, since we can put it in any base we want, we can do base 10 and we can do natural logarithms on the calculator. So in particular, if log base C of A, I can either use base 10, log base 10 of A, or divided by log base 10 of C, or the natural log, which again is log base B of A, over the natural log, or log base E of C, because I can do those on the calculator. So it's going to ask you to do things like evaluate log base 3 of 8 using common logarithms. Remember, common logarithms are base 10. So if we go to the Desmos calculator, we can just simply go, have to go to functions, and we're going to go miscellaneous, and we're going to use logarithms. So that was, if we go back, it's log base 3 of 8. So that means we're going to do log base, to do this, we're going to do log base 10 of 8 divided by log base 10 of 3. So remember, if we don't put a base down, it's base 10. And now we go to the graphing calculator, and we're going to do log base 8. So we're going to do log of 8. Close our parentheses. Divided by, go back to functions, and go log of 3. And it tells us it's 1.8927. So they'll probably have you rounding to the nearest thousand, so 1.893. Now here's the thing. If we wanted to, we could have done that with natural logs. So I'm going to use the same one and do it with natural logs. So if we go back to the calculator, and instead of log, let's do ln. So if I do ln of 8, and delete that, and do ln of 3, you see we get the exact same value, 1.8927, so 1.893. So it doesn't make any difference which one I use, I will get the same value. They're going to either let you choose or they'll tell you which one to use. It becomes more important as we go on later on because you'll have to use the ln when you get to where you're working with base E, and so you'll want to convert it to this in those cases, but we'll get into that in the next section. So if we look at the next one, log base 6 of 24 using natural logarithms. So we're going to go back and do, using natural logs, that would be ln 24 over ln 6. So if we go back to the graphing calculator, ln 24, ln 6, we get 1.7737, so 1.774. So again, it's pretty easy to do either one of these. You type it into the calculator, you just go log, if it says use common logs in this case, so log 8 divided by log 3, because that would be base 10 or common log. And if it says use natural logarithms, it'd be ln 24 divided by ln 6, and you just type it into the calculator and you get your answer. So let's check on this. It says use the change of base formula to evaluate. So they're letting you use whichever one you want. You can just do them all the same. You can change them. It won't make any difference. You'll get the same value whether you use common log base 10 or the natural log base e. So go ahead and pause the video, try those, and then come back and check it. So you should have either set this up. Again, you can do it either way. Log 8 over log 5, or ln 8 over ln 5. In either case, you'll get the same answer. So it's totally up to you which way you did that. But if we go to the Desmos, so 8 and 5. So I'm just going to do it as logs. So log 8 divided by log 5. And you should have gotten 1.292. So this should have been 1.292. Again, we're going to round things to 3 places. So the next one, I'll just do it in natural logarithms. It doesn't make any difference. So 14 divided by 8. So we can just change it real quick here. And we get 1.269. So you should have gotten 1.269. The next one would be log 9 divided by log 26, or ln divided by ln 26. So 9 and 26 we're going to do. And we get 0.6743, so 0.674. And the last one would be log 30 divided by log 12, or ln 30 divided by ln 12. So 30. And we get 1.3687, so 1.369. So hopefully you'll find that these are fairly easy to go through. Again, please on your paper write down any questions you have on this lesson so that we can go over that before you get started on the assignment. But the assignment for 6.5 is page 331, numbers 3 to 39, the odds. And hopefully you'll find this a pretty easy assignment to do. So, good luck.